Good evening, everyone. Okay, yeah, thank you, Mr. Software. So if you can hear me, good evening, everyone. I want to see from the comments if you can hear me and you can see my screen. Good evening, you are welcome. You are welcome, Yetunde, Adegoke. You are welcome, Isaac. My last class, I saw Isaac. Yeah, Isaac. Innocent, Amandi, Eniola, Damilola, Life Guide, Stancy Vicent. Yeah, good evening, Olarewaju, good evening, Adekemi, good evening, Damilola, Faith. You are welcome. You are welcome. You are all welcome to this class. So I want to see a good number of people. Again, I'll keep saying everybody must code and everybody must do something, right? Yeah, good evening. Good evening. Onome, correct. Charles Adebisi. Great, thank you. Good evening. You're welcome. So my name still remains the same. Blessing Olonfemi. Then can reach out to me on my LinkedIn. Okay, good evening. Okay. So for this class, we will continue from where we stopped. Or when we stopped last week, and from where Oluwole and Isaac, from where they stopped to, what did they taught us? So we want to apply it to what we have been doing. Some of you have reached out to me on I think on LinkedIn, then having issues with their code, which we have rectified. A lot have reached out to me. Some have not replied, right? So Edith, good evening. Good evening. So we are working on something like a platform where we can reach out to everybody. Can reach out to everybody. Now, Kent, Amarashi, yeah, Amarashi, good evening, good evening, good evening, good evening. You're welcome, you're welcome, you're welcome. You're welcome, everyone. So we will be doing virtualization today. Using the Matplotlib, Seaborn, and then some of the library. We've seen it from the beginning that all these import libraries, they are useful for our work, very, very useful for our work. So by now, I want everybody to get their laptop ready, open your Anaconda Navigator. Next week, I will ask us to open Anaconda Navigator. I'll just tell you to go open your code straight. Let us start, because next week is going to be more of we're applying the AI models, algorithms. We'll be playing with the algorithms. So for this week, we want to see outliers. We want to see the outliers and how things is being done for this class, visualization of our codes. Right. So I don't know if I should. Okay, let me stop my screen and share it all over again. Okay, thank you, Isaac. Thank you. So this slide is just about I think 4 or 5 slides. 4 to 5 slides. And just a summary, then we'll go back to our code. So last week we started with using diabetes similarities data set. And then I said that you can download any data set from Kaggle that you want to work with. For some of you that want to work with finance, or you want to work with agriculture, or you want to work with data set, that is data set now, I'm talking about data set. You want to work with politics, you need data set for that. And then if you are already working or you are in an organization, and you want to analyze one or two stuff, you need a data set. And we have talked about data sets from, I think, our second class. Talk about data sets, organized codes or unformatted raw data that you need to clean, you need to work with. So we've talked about that. And then, so for this class, we'll be doing exploratory data analysis, EDA. We'll be looking into the histogram, plots. Then from the code, we'll see what histogram wants to work and is doing. We'll be working with voice plot. Voice plot, most times, when you use voice plot, most times, if you want to detect outliers. I believe Oluwole and Isaac, they have dealt with outliers. Now, when you have something extreme, you have something so extreme from your normal code. For example, we have fruits. I was in a class this week. I was taking them. I taught them. I was taking listing in Python. Then I said, let us list fruits for I in fruits. Do this. I was talking about listing. Then we were talking about fruits. So we are talking about what type of food do we have? We have different type of fruits. We have apple. We have what again? Banana, cherry, different type of fruit. Imagine in the fruit, I'm not putting like monkey. I'm talking about fruit, but I'm putting like monkey. I'm putting like fufu. I like talking about fufu. He likes. So it is somehow to get me. It's an outlier. Like this thing is not related. So anything outlier is not related to somehow out of the box. So for this class again, we're talking about count plots. We will be using count plots for our distribution. It's more distribution than heatmap. Majorly the histogram, the bus plot, the count plot, heatmap. And why we're using this EDA is to identify key data issues before serious cleaning. Before we do serious cleaning. And I'll make sure in this class that I try on my best again to calm down. On my best, I'll make sure I try my best to calm down so I will understand what we are doing. Then also to replace or remove, we're going to do removing zeros in our codes, removing zero from the features and adding outliers, and also apply feature scaling or normalization. This and optional something. Oluwole taught us about feature scaling. And our focus here remain get a data set. Then I want to work with diabetes similarity data set. I don't know about you if you have another data set you want to work with, but I will prefer if we all are using the same data set. Then maybe after this class, you can get your own data set and use the same example or the way we are structuring the codes. You can apply it to your own work. Then we'll talk about features. There are features you need to consider in data set. Features like, okay, we're talking about heart disease. You have features like glucose, blood pressure, BMI, age, and the outcome. So I want everybody to open their search, type Anaconda Navigator. Then what concerns us for this work is either we want to use Jupyter Lab or Notebook, but let us use Jupyter Notebook. So now I'll be sharing my own screen. Okay, someone say banana, sorry. I'll be sharing my screen now. I'm dropping the screen then to share my screen. So everybody open Anaconda Navigator, then Jupyter Notebook. If you are on your notebook, please, I want to see you saying, yeah. I'll try my best to be still calm. And I believe I'm going to set this on fire. What is the difference between lab and notebook? Okay, the difference between Jupyter Lab and notebook is they discovered that Anaconda those guys that did those stuff, they discovered that Jupyter Notebook is just for offline, and then there is no GPU. So the difference is just GPU. Jupyter Lab have little bit of GPU. For some of you that don't know, Jupyter Lab have GPU, just like Google Colab, just like Colab. That's GPU, like Colab. Right. I believe you understand now. So yeah, if you're on your Jupyter Notebook, yes. I believe the admin, the admin have sent or forward our stuff to us. The code we want to work with today. Still the same code, we'll continue from there. Yes. Okay, thank you, Joshua. Thank you. Yes, I'll be dropping my screen now, and then thank you. There's no send code. No, maybe you should check your mail again. Okay, thank you, Oluwole. Thank you. Yeah, graphic processing units. Thank you for emphasizing, and then yes. Everybody open your, by now, before I drop this screen, by now I believe everybody should have an Anaconda on their system. And if you don't want to have an Anaconda, you should have Jupyter Notebook. You are using Jupyter Notebook. Your system just got damaged. Goodness, what happened to your system? From stage. Okay, so Anaconda Notebook. Then click on Jupyter Notebook, and Anaconda Navigator. Then click on Jupyter Notebook. That's what we want to use for this class. We'll continue from where we stop for the last class. Where we stop, we'll just continue from there. Then we'll ship in the EDA, we'll ship in the mean, median. If possible today, we can ship in this Skillup. For those of us that are using PyAndroid, by now I don't think we need PyAndroid again. I think PyAndroid is just for basic mathematics. I said you want to run your code in scripting. Can you see my screen? I'll try my best to be calm to make sure everybody can see and just flow together. Okay, so for if you don't know how to navigate, I'll be explaining. Everybody, please listen. If you have opened Anaconda Navigator and it's showing the Anaconda Navigator, our consign for this class again is Jupyter Notebook. Then move straight to your DSC. You remember you created a DSC folder, right? So move there. Then our work for week 2, we're bringing it back. So just go and click on it. Click on our work. So simple. So if you're on your screen now, you're on the data set that we got. Please, I want to hear. You can say yeah. In my class, I like saying yeah. But for this class, you can say yes. If you're on your screen now, or you're on Jupyter Notebook, yes. This class will be you will enjoy today's class, but you make sure that you are calm, like you listening, just calm and listening. Yes, thank you. I want about 70% of this class, 70%, at least 70 to 80%. Dataset, by now, you should have, okay, what you do is go to Kaggle. If you have not downloaded the dataset, go to Kaggle. Yes, go to Kaggle, then look for diabetes mellitus, diabetes data set. Yeah, thank you. Then download data set, open a folder on your desktop, send data set inside. Then open an Anaconda Navigator, go to, I've explained all this in last year, last week, I say last year. So go to Jupyter Notebook, then go to DSA inside the Jupyter Notebook and open a new folder. Ready, thank you. Okay, Shay, thank you. Please drop link for data set. Who said I should drop link for data set? Paul. Were you in my class last week? Paul, were you in my class last week? Download the data set. Okay, yeah, we have about 70% now. Please, my Jupyter Notebook is not seeing my desktop. How? Okay, if your Jupyter Notebook not seeing your desktop, your Jupyter Notebook should see your document. Check if you see document there, then go and open a folder in documents. Yeah, thank you. Okay, I think a good number of people are ready for this class. So we are good to go. So last week I said, we are trying all our best for this class now. If I'm to teach or take all the codes, Oluwole or Isaac have, put us to, the taught us, maybe in the next 1 year, because I have to explain one by one. So I'm trying my best to make sure we are getting the right thing at the right time. In the sense that I brought in something like problem statements. For every work or anything you are doing, there should be problems to. Oh, thank you, Sonia. Emmanuel, thank you very much for the data set link. Yeah, go to that Kaggle. Thank you very much, Emmanuel. Thank you. We have explained everything the last week. You can check the class for last week. You'll see everything is well explanatory. Now for this class, we said we need a problem statement, right? Problem statement is, why are you downloading data set? Why am I studying AI ML model or ML artificial intelligence machine learning? Why did I want to know it? Why did I want to know how it's working? When I'm done, what did I want to apply it to? Right? So we need to know. You need to know why you are studying it. If you are done, okay, I'm done with Python. I know how to use Python now. I know how to write code now. I know how to do machine learning analysis. What do you want to apply it to? What do you want to solve? So that is where you see something like problem statements. So in the real world, or when you now start having clients, or clients is now contacting you, you'll be asking different questions. What do you want to do? What are you solving? You get me? So last week I was able to say we're working on diabetes mellitus. Then what's diabetes mellitus? One thing unique about diabetes mellitus or diabetes is blood sugar. And they're getting data set for Nigeria corruption. One thing about that, the corruption, or Nigeria is corruption, Abi. One thing that you want to solve is corruption. So you need data set for corruption. By getting data set for finance, bank, what do you want to solve in the bank? What do you discover? Like, I was discussing with a friend. And then I was like, everything I'm looking at now, I'm a researcher. Like everything I look at now is I'm looking for a problem to solve, problem statement, right? So while I was doing that, I found out that we have different type of diabetes. We have type 1 and type 2. And again, while I was doing, I still went deeper doing the break. Okay, doing when I was not taking my class, I discovered that we have another type of diabetes, gestational diabetes. It happened to women that they are pregnant women, gestational diabetes. So for this work, we are trying to detect, we're trying to bring in a model, build a model. We're trying to build a model that should be able to detect diabetes early. But you can say, oh, I don't want to work with health, I want to work with finance. build a model that can detect fraud detection system, right? Another person can say, no, I want to solve problem that can, that solve all this cheating problem in education. Someone contacted me on LinkedIn, and I think she was like, I want practice education. I was like, okay, get data set. That means you have to get data set for education and see how you can solve that. So last week we dealt with all this stuff, and then the first thing is we needed our libraries. Before you used, when you get to models now, the AI, the algorithms that we're using, AI is algorithm, machine learning is algorithm. You are the ones you are training, supervising it. This is how I want it. When we get there, I'll explain. Then I will try my best to be saying. I'll be saying a lot of stuff, a lot of things, stuffs. Yeah, in this class. So if you can just grasp, just calm down and flow. So for machine learning models or algorithms, or anytime you are doing anything, you are working with um, digital lab, you want to build a model, you need libraries, a lot of libraries. And the first class, we downloaded our libraries for pandas, pip install pandas, pip install numpy, pip install matplots, and the likes. And the last class, there was not matplots on the libraries. That is first something you can check from the last class. There was no matplots, but because we are using matplots in this class, we want to visualize, we want to see how many people are suffering from diabetes, and people that also that other people that have diabetes and people that don't have diabetes. We want to see that in this class, right? Hope I'm saying a lot. Hope I'm not too fast. And people are just complaining I don't have laptop. For those that are using Pydroid, right? Um, from depth of my heart, I advise you, sir, to get a laptop. I advise you to get a laptop. Because some of these libraries that we want to work with, you won't need it. Please zoom your screen. Okay, I will do that. Let me zoom. I think it's zooming now. Yeah. Can you see it now? Okay. Can you see my screen now? Can you see my screen? Sorry, your screen. I've zoomed it. Can you see it now? Better. Okay. Thank you. So, for some of you that are joining us again, maybe you were not around last week. Can you open the digital notebook, and the first step, run the first step, run this first code. Last week we were able to do, we stopped at, I want to zoom this thing back. We stopped at I think last week we stopped at yeah, described, by describing. Then this week, this is what we'll be doing this week. Just let me just show us, and I will be explaining the code one by one using pie charts. Then I'll be teaching us how to prompt ChatGPT or Copilot for your work. I'll be teaching us how to prompt it, and you're giving us our answer. Okay, thank you. It's better. Thank you very much. Now, I'll start again from the beginning, then just is it the makeup class for us to understand again. So now we have diabetes mellitus. Talk about the event about diabetes mellitus. The first thing first we need is our library. First thing first we need our library. We need our pandas to download our data sets. Now, if you see something in this place, PD, fast, but not too fast. I have something like pandas, import pandas as PD, import numpy as NP. Then you can just press enter, because we want to make use of this matplots. Matplots is for visualization. It's a library. You can just press enter in your stuff, then add imports. I'll do that now. Enter imports. I'm typing it again. Imports Matplotlib dot pyplots as PLT. They are for plotting, actually. Right? They are for plotting our code. I've entered it twice just for us to know. Then last week I said, instead of going up here, see my cursor, instead of coming to run this cell, instead of running this cell, you can just on this place, you can just on your laptop, just shift enter, just shift enter. I'm doing this because I want smartness. Shift enter. Then you wait. It's loading because I start my kernel. Shift enter, no error. Shift enter. So if you're not having error on your code, it shows that you have installed this library, Matplotlib. It will get to a time that some of you that are using data analysis, after this code now, you get to a time that some of you are doing data analysis, you want to run back to this Incubator notebook, because when I start visualizing and I start explaining, like, so small code can do this stuff, right? Yeah, run shift enter key. Thank you. For those that are having video clarity problem, you should click okay. Thank you, Faith. I have error. You have error. That means you need to. What is the error? I'm not supposed to be solving the error, but what's the error? Oluremi. Because this is the first one. We have done this one last week. What's the error? Irene. Okay, Irene. Done. Thank you. What's the error you're having? Oluremi, can you please be fast? I believe it's saying that Matplotlib or Pyplit is not there. PLT is not there. Right. And then okay, thank you, Yetunde. Thank you. Let us continue. This may take a moment. A spirit aflame done, I guess, is your stop. Let's continue. Yeah, we'll share this slide with you. Let's continue because of our time, because I have a lot to do. I don't want to go back again. Then that's for that. You need to run that again. Then last week we talked about the pandas. Now see where this panda is coming from. Pandas, PD is to load your data set. I told you last week that your data set should be inside where your code is. When you're running your code, your data set should be inside. And then it's simple. For those of you that are seeing, I met one of the students, and the person was like, it's like it's getting tougher. Hey, it's not tough, it's very, very simple. So run this code, run this cell to show the first five. This dot head is showing the first five column rows of your data set. Rows of your data set. And there's a reason why we're using data set. Now, I said 5. Someone will be confused. Computer or programming will start with 0. I'm just trying my best to make sure I'm simplifying something. I don't want to go deeper. Like indexing, start from 0. In the actual sense, in the real sense, people say it's 5. Like 1, 2, 3, 4, 5. But when we are reading something, it starts from 0. 0, 1, 2, 3, 4. Right? Then it's showing the pregnancy. But if you open this data set in your Excel, same thing you are seeing, but you are seeing it in a beautiful way now. You open this data set in your Excel, you see the same thing here. Then you have seen 61810. For glucose, you are seeing 148, 85. Then for blood pressure, you are seeing 72. I believe you'll be seeing that in your code. Insulin, I've seen 00000. Then when I do this part again, df.tail, run this part again, that's run the last 5 tail, the last 5 rows of my data set. We have 768 actually, but because we start from the 0, it's giving us 767. 767. My screen is zoomed enough. I've zoomed it enough. Except maybe don't say anything again. Yeah, thank you. So let us run for tail 2, df tail. If you have run that, done. If you have run that, I want to see yes. So I'll do it together. Okay, something. If you have run df.pay again, I want to see, say yes, yes, yes. Done. Thank you, Twain. Thank you. Done in last class. Thank you. Thank you, Today. Thank you. Done, done, done. We'll do together. What I want us to do it together. I can just run everything because for those people that did not join us last week, I believe we have done this part. Right. So let's go to the next one. Done. Then the next one too, I think is okay, I ask a question then. Df dot shape. Df dot shape. Just df dot shape. Let me run to for my end. Df dot shape is giving me 768 and 9. So this is different from attributes. Now, someone will be asking, why am I not putting what are they calling it? Bucket. Why is it not there? So it's different from we are just doing normal attributes, or we are doing I'll be explaining this later. I'm saving a call. Okay, so let us df.info. I guess you have done this. If you have done that too, please, I want to see done df.info. You want that part too. The shape is telling us we have 768 instances. We have 768 instances in machine learning or data science. We call it instances. Then we have 9 features. How do we have 9 features? What are the 9 features? On the group, on the comments, what are the 9 features? In the comment section, the 9 features. Can you please show me 9 features? I think I explained 9 features last class. We have 768 instances and 9 features. What are the 9 features? Anybody? 9 column. Correct. Okay. 9 column. Can you mention the 9 columns? Either. Okay. What are the 9 features? They are features. We call them features. 9 columns. Yeah. Can you mention one of them? Ogeshuku, you are having issues with your laptop. I think it's your laptop. Yeah, the column name. Okay. Shei, insulin. Yeah, that's what I'm seeing. Insulin, pregnancy, outcome, pregnancy, the outcome, glucose. Correct. That's what I'm seeing. Beautiful outcome, insulin. BMI, body mass index. Beautiful. Now, when in data science, when you look at data science AI, when you look at data sets and they're saying features, instances, and the like, you should also know that those columns, the 9 column, the top, they are called features. We deal with features most times. She gets me. We deal with the most important features. In one of my paper I wrote on diabetes mellitus, I deal with the features. I pick the most important features. Like I wrote a code that will pick the most important features. I guess before the end of this class, I'm going to give us an assignment, right, to write a small code that pick the most important features to your to what you want to do, to what you want to predict. So skin thickness, correct, age, and likes. So thank you very much. Let's continue. And I just correct. Then the info. I also want this to df.info. 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 So this information is giving us the data type. It's more of the data type, right? Now, from this information here, I won't go, I don't want to go deeper. Like let me just explain in a fair, like just in a layman language for some of us. Now, for pregnancy, we have integer 64. It's telling me that all the information in pregnancy, they are all integer. And 64 bits. My computer is 64 bits. Right? I don't know if they are still producing system that is 32 bits. I don't know. the bit. I won't go deeper. Let me just now. What glucose 64, blood pressure 64, skin thickness 64, insulin integer 64, BMI float 64, diabetes pedigree function float 64. Whole number, integer is an whole number in computer science or in programming. Whole number, integer, 1, standing on its own, 10, glucose, 10, blood pressure, 76, skin thickness, 48, insulin, 180. But BMI, body mass index, diabetes pedigree function, we have 32.9, floats. Anything decimal in programming. In programming, we call it float. We have string, we have integer, we have floats. Diabetes pedigree function is 0.171. There are guys that are good on this. They're already good. You already know this how it is. But for some of our guys that they are trying to understand how this thing is done, I need to explain, right? So that is how all this, we got all this stuff. Telling me that we have integer, whole number, that when it gets to BMI is decimal point, like the something is in decimal, right? Something point something. Are you with me? If you are with me, say yeah. I like saying yeah. If you are with me, say yeah. So that is for that. Okay, now then we do check for basic statistics. So does this DF describe all this describe the input function that you need to know? Oluwole have taught us, he has showed us all these basic input Python functions. Now, for me, I call it the program that you need to know. Last week, I was saying that if I enter a place and I'm speaking Hausa, Nakwana, Lagajia, Lafia, Kalo, or Otutuoma, all these different language, like I need to know this language. So all these input function, those basic input function that needs to be known. That's why we just need to know the DF information of the data set you want to work with. Then when we get to the where we need all this information, you understand better. Now, what this DF describe is doing is doing a total count for pregnancy. The total count for pregnancy, that is just telling me the total number of the rows that we have. 768 total number, 768. Okay, like then it's giving me the mean value of each row. You calculate the total number of pregnancy, that is for the row. Then mean now, the way the mean is being calculated. Oluwole, Isaac have taught us about that. The glucose, these are the basic statistics. Some way, imagine just one code, one inbuilt function is doing this, right? So just one inbuilt function is doing this. Standardization too, one inbuilt function is doing this for each row, row. So I have to explain all these things one by one again, but this way we stopped last week. Then from here, we take it up from here. Then everybody should be ready to type 1 or 2 codes. I believe they should have sent this material to us, or if not, we'll type. Better we type it ourselves, then learn, and I'll be explaining. So that is for that. So one code is doing this. Then when it gets to minimum, we are seeing is 0.00000000000. So you begin to notice something is 0.00000. In your data set, if you are seeing 0.000, something is wrong with the data set. Is that maybe the person that was inputting data set he did mistake, or something is also wrong somewhere. So we'll be mindful of that 0. Then the 25 percentile, I won't use a calculation stuff. 25 percentile, 50 percentile. In those, no need of you doing the calculation. Actually, I'll just explain. 25 percentile is just 25% of the way they calculate it. 50%, 75%, and the maximum. I believe you should know that. Like, I'm giving you 100,000 naira, and I say you should pay 20% to so person, or pay 20% to Oluwole, or pay 20% to Isaac, or I'm giving you 100,000 naira, I say you should pay 25% or 50% to DSA. Wait, oh, DSA, thank you for this wonderful course. I want, Mr. Blessing gave me 100K. I want to, pay some amounts. So you should know how this is being done. Like, no need of doing the calculation. Now, for this class, make sure you only describe and see it, please. Now, for this class, we are going to virtual EDA, exploratory data analysis. So we want to see something now. We want to see the total number of diabetes, the people that have diabetes and people that do not have diabetes, right? So I did another code again to design it, just to design something. This is beautiful, very, very beautiful, right? Very, very, very beautiful. So you can come up with your something. Then from here, I'll be teaching us how to use pumpkin. I'll just tell you, go to so place, then type so, do it and come and paste it and run it. That's what I'll tell you. So from here, I'll tell you what to do. It's very, very simple, very, 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 very simple. Now, so here we'll be doing virtualization. Want to see total number, then want to see the total number of BMI, total number of people that have insulin. Want to see that in our code. I'll be asking questions, do the code, then come back here and say, yes, I've done it. Yes. Okay, describe statistic. Okay, thank you. Just follow. If you don't have the material, just flow with me. There are people that are already on their system. Just flow. I will just describe this, then you do the code. We're good to go. So for basic EDA, you know that Excel can do this. Excel, basic all this statistical software, they can do all this stuff, right? But someone came up with something like, why can't you just write few codes, few stuff? Why can't I do something that can manipulate? Sometimes before you manipulate in Excel, it takes a long time. Summation X, column, this one, write this one, put this one here. So you have to be sometimes be thinking like a statistician or mathematician, right? But in Python, 2 codes can do your visualization, right? 2 codes can do your visualization. But let us leave that. In this work, we are working with diabetes mellitus. I'm trying to bring us back to health now. We want to see how health affects, then we want to write a model on this stuff. Then the basic visualization EDA we have voice plot, we have Violin. Violin is not here, but you will try it. And you say done. I'll tell you how to get it. You try it and you say done. We have histogram. We have voice plot. So voice plot is used mostly to check for outliers. We'll look into it. So those outlines that Isaac was talking about, Oluwole was talking about, we are going to set it on fire. In this class, right? Then we also have value count. We have value count. You can maybe you have a Bible, you can put that down, but we can see it on my screen. Then we'll share this code with you later. This notebook, we'll share it with you later. So now we have histogram. This histogram is used to check the distribution of numerical features. We want to check for the distribution of numerical features, and like we want to check for the distribution for glucose. We want to check for distribution for BMI, body mass index. We want to check for distribution of diabetes predictive function. We want to check for the distribution for age, the total number of people, the age group. I'll tell us what to do. You'll be the one doing it. I don't know everything is here, but now as I'm talking now as a researcher, I'm seeing gaps already. Oh, what if I put this one here? If I do this one, I do this one like this. We do this stuff. So everything about histogram is also check for distribution on how it's being operated. So it may also identify skewness in features like BMI. So then we have Boyd plots. Boss plot. I'm calling Boyd plot. Boss plot. What browser is it to check for outliers? Outliers is those numbers that are skewed, like they are far away from the from the data, right? So we'll be doing that. We want to check and look for that. Histogram is to join bar chart, correct? Yeah, bar chart is more bar chart. It's more of bar chart, right? So sorry. So for data, yeah, thank you. Thank you. No, the material will be sent to us. I'm having a lot of calls. Yeah, so voice plot to check for outliers. So just follow. Count plots, class distribution. So use cloud plots to visualize the class distribution in the outcome, guys. And what count plot does is it focuses on the target variable. Hope that English is not too much. Target variable. Data set is more of the data science, or AML, AL is more of getting data set, then trying to predict work on patterns and trying to create a target variable that based on these features, this person have social disease. Based on these features, this person maybe heart diseases, right? So it's more of target variable, but our target variable here is outcome. Let me explain this again. I'm going back to this. Based on pregnancy, glucose, blood pressure, or see this first person here. This first person here. I said this was one. This first person, this let's say client or patient, pregnancy is 6, glucose is 148, blood pressure is 72, skin thickness is 35, insulin is 0, BMI is 33.6, diabetic PDB function is 0.627, age of the person is 50. Now, and the outcome shows that the person have diabetes. Outcome, target variable, that outcome here, this outcome here, you can see it on screen. This person have diabetes mellitus. Last week, somebody say, how will person have pregnancy 6? It means that the total number of pregnancy the person have like, I won't say Yoruba, I don't know if I can speak Yoruba, Omoto TB, right? So when they check the glucose level of the person, is 148. I shouldn't be explaining this actually, but in case you get another data set, you can use this to explain your data set. Either as finance, know what you are doing. Just know what you are doing. That data science or machine learning make you to do research. You have to do research, just small research actually. You know that maybe you should know everything, but you should know what you are doing before you start working with your data set. So this second person, the glucose level of this person is 85, the blood pressure of this person is 66, the skin thickness is 29, the insulin of this person is 0, which is not going to make sense. The person cannot have 0 insulin. Then this person is not have diabetes. Is 0. 0 means no diabetes. 1 means diabetes, right? I can say no diabetes, diabetes. Diabetes most times happen to I'm talking that back. So the old age. So it was speaking Yoruba. So now, so I said count plot. Count plot is used for it visualizes the class distribution in the outcome features, right? In the outcome features. Now, then we have heatmap. So heatmap is a correlation heatmap. A correlation heatmap will help you identify any strong correlation. So what heatmap generally is doing is strong correlation. I use in my work most times when I'm working with numerical data set. Numerical data set is different from image data set. I use heatmap and heatmap. I use heatmap most times to note some correlation. I will explain this for us. I will explain. They are very, 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 very simple. So when sometimes you see heatmap, this is heatmap here. Let me just go down to where heatmap is and show you strong correlation. This is an heatmap. This heatmap. So it's looking somehow a bit, but after explaining this, very, very simple. This is an heatmap. We'll do that. It's a small code that we can get the heatmap. So when I'm working with classification numeric data set. This data set is already in numeric data set. Numeric means is in numbers. They've transferred it into numbers for us, right? So we can be using the class distribution, the heatmap stuff. So that's for that. Now, first thing is, so we saw count plot, we saw bot plot, we saw histogram, we saw heatmap. So let us first, we want to know the total number. So we are using value count. This is where the count is coming from now. Value count. Then our target variable should be outcome. Should be outcome. Now, on your, after when you're done with this, we are done with this. Next thing is EDA. Sorry. Just print. Look at this. I'll be typing. We'll typing. Let's type together. Under it, print. Open bracket. Close the bracket. We want this. Then when we are done running, you say done. So we want to see the total number of people that the outcome. Total number of people that have the total number of people that have diabetes and people that don't have diabetes. That's what we want to see. So now, everybody on your system, go back to your system. Let us type together. Print, open bracket, df, the square bracket, that is square bracket, call it gray. Then inside it should be your column. Those your quotes. Our target variable is outcome. Please be careful with your spelling. The spelling, the outcome there inside your data set is, the first one is capital letter O, capital letter outcome. Hope I'm not too fast. Outcome dot, sorry. Then the back of the square bracket dot value count. Tell me to count the total number of simple code, just these simple codes, and I can modify it. Then close the bracket. Count it and run. Now I have 2 here, but I want it to show me 2 answers. You show me that it's 0 people. 0 is what? 0 is no diabetes. 1 is diabetes. So it's because of I have to put there, right? So what if I say I'm coming while you're typing? I want to do something funny. I like testing one to start. Okay, BMI. Okay, the count is 13. I want to explain this. What concerns us is outcome. Actually, what concerns us for this class? So I'll do the virtualization. Outcome, and run. You run. Okay, so if you have done that, yeah, it's more like area of concentration. Yeah, correlation, strong correlation. It's not strong correlation. If you have done that, yes. Run your code and say yes. Then tell me the total number from the same end. And people suffering from diabetes and people are not suffering from diabetes. Done. Gambo. Wow, people are fast today. We must finish everything today. Anything we must finish it today. Today. Done. So you understand this already, that 0 people, you have 500, that is 500 people do not have diabetes in data set, and 268 have diabetes. Machine learning ML model, they rely on data sets. They want something, they want to eat something. They want to see, right? Okay, so I think the class is following correct. Abimbola, Sonia, is that this Sonia? Olayinka, whatever. But now it's not very this so 268 have diabetes. Now, in our next class, I'll be explaining some stuff to us. Looking at stuff, I'll continue, sure. But looking at this stuff, there's something called smooth. Well, you have to do research, smoothing, balancing, and the likes. Let us continue. Done. Yetunde correct. Oyeni correct. Done. So now, that is for that. I'm removing this one. Now, we want to visualize. This EDA. Visualizing. So the simple code for visualizing is count plots. So we have this code. I already know there's an error here because we know there's something that's not here, but I'll tell you what we want to do. But I want to do it, so I'll show me the error. But for some of us that are smart, that have already going back to this place, that have already put Matplotlib, then Seaborn. We need Matplotlib and also Seaborn in our, I don't know if Seaborn is here. I'll look for it and put it. Seaborn. Seaborn is also a library. So now, we want to visualize what we got here. This is 0500 and 1268. We want to visualize it. So this is just a simple code saying that we have xnx dot count plot open bracket. I'm declaring a variable for x, capital letter X is equal to, funny enough, when I was doing this code, I'm not typing like this. I'll tell us what to do, but first for us to understand, data is equal to df, right? Then I don't need this. Type it. Okay, just type what is on your screen. Type what is on your screen and run. To visualize, type what is on the screen and run. Seaborn is SNS, correct? Yes, Seaborn for heatmap, correct. I deliberately removed that library, but I want us to see if one of you is going to have issues also. So I'll tell us what to do. Yes, Seaborn for heatmap. I'll deliberately remove it. So why we are doing that is not SN is not fine. Don't start. Yes. We'll fix the error. Yeah. So now there's something I'm looking for. DF SN is not fine. So there's something I'm looking for here. What I'm just looking for is you need to make sure you install. Just put a space here and put this library, this Seaborn. For everything you are doing in machine learning AI, or you want to do visualization, you need a library actually, a library for it. And sometimes, if you don't have the library, it will tell you, you see the error, essence also something is not there. What you do most times is, I want to be sincere, use LLM. Sometimes even before you shut me up, like a lot of people are shutting me up on LinkedIn already. Like it's not even everybody I can reply. Like most times is the library, the having issues with the library. So what do you just copy the error part? Just copy the error part, then take it to LLM, ChatGPT, Copilot, and you just put it there. And prompt ChatGPT, please, what is missing? Ifa, I call it Ifa. Ifa, Ifa Yoruba. Ifa will give you the answer. Then just copy the answer and put it back. So, I used 2 years to learn this stuff. And now that there's now ChatGPT, there's now all this stuff. It's just easy for me now. If I'm running any code that I want for 2 years, with this stuff, I'm good to go. So if you put this on import Seaborn as this one, you run it will show you the total number of people that have diabetes. You'll have seen 500, and people that don't have diabetes 1, people that don't have diabetes, right? So if you have done this, I want to sit down, we'll go for a break, then we'll come back to check for burst plots, check their clients for burst plots, heatmap, the heatmap. Then do a little bit stuff again. There's a lot we need to do. I'll give us assignment. Just play with it. Correct. Yes, done. Thank you very much. So I've fixed it. Those people that are having issue with Seaborn, just import Seaborn. We'll have seen it in the code. Yeah, import Seaborn as SNS. Right. Import Seaborn as SNS. Correct. It is not clear, sir. At DBC, why is it not clear? We want to just do value count. We want to know the total number of people that have diabetes and people that don't have diabetes. Visualization. We want to visualize. Simple. Mr. DBC. So, and this is the code to visualize. This is the code. Just type the code here and run it. Total number of people that have diabetes and people that don't have diabetes, and put this code here and run. Yes, Excel can do it. Somebody said Excel can do it. I was talking to someone, Excel can do it, but when you get to time, when you get to one place, you know that, I need Python, I need Python, I need Python. Don't. It is where, Moses, why do you say it is where? I think we are going for a break now, and then we have 3 minutes break. Let's say 3 minutes break, so that we'll continue to voice plots and heatmap. I'll be giving us real life, like life assignments now, like classwork. We'll just do it together. I'll just try to change something here. Now, okay, change something. Instead of you can put one, instead of one, you can put two. Just change something while we're going for a break for you to take your attendance. Attendance time. And thank you, Bong. Ask ChatGPT or DeepSeek how to impossible. It's there. I put it up. Impossible. So you can go for a break. Then we'll come back and we'll continue. Thank you very much for following the class. Yeah, please, if you can still hear me, I guess the attendance is already posted. You can take your attendance. I don't know. You can take your attendance now. Yeah, okay. I guess we are done with our attendance. Okay, I'm still a lot of done. Correct. Thank you very much. Thank you very much. So much I should explain. So we need our Seaborn, it's a library. Then we want to, most times, just I want you to think like a programmer. Last week I said anything you can think, you can code. Anything you can think, you can code. Anything you want, and then you can do anything you want to do. Like I want to do a bar chart. I want to create a bar chart, EDA, visualization of what I want to do, right? Then I want people to, like, when they look at my bar chart, they should describe what I want to do. Somebody say no title. That means to say you don't put the title there. You don't put the title inside. So anything Seaborn, anything Seaborn, if you see SNN, you see PLT. This PLT is for PyPlot, Matplots. All these things there, they're just inbuilt function, they're libraries, input function that you are calling, right? So we need this first one to count the count plot. Go to outcome, then outcome, that is data, the data DF. Go there and count for me the total number of people that have diabetes and people that don't have diabetes using this count plot here, this value count. This value count is telling that we have 500 diabetes and we have 500 people that don't have diabetes. 0 means no diabetes and 1 means there's diabetes, right? Please get this stuff. So that's what it's doing. Then this py title is saying when anybody look at my code, though, this code, when I run it, to tell me that distribution of diabetes outcome, this is the total number of people that have diabetes and people that don't have diabetes. Then this S label and this Y label, right? So the Y, like this X and Y, X, Y, I think Y, X also, yes, Y, Y, X, right? So to tell me, you say, okay, no, sorry, X, Y. So this one should tell me, this for the X label, we have, the outcome should be no diabetes. I don't have this one. I can change something here, just say someone or something here. As a programmer, I believe when we went for the break, you should be able to have changed. Okay, what if I remove X here? I remove X, I remove E, and like. If I remove this one, I remove this one, should be able to give me this thing. Then for 1 should be diabetes. Then should everything count and show me the virtual that I created. Okay, what of if I say I remove all these parts here, I remove all these things here, I just put distribution and I run. If you always show me distribution, it always show me distribution. Can you see? It always show me distribution. What of if I remove 1 and I put 3 here and I run it, it will show me 3 in this place. So we're just like our supervising, we're telling me this is what I want, this is how I want it. Right? So I'm just trying to explain what that is doing. Now, the next, let us go to the next one. Let's go to the next one. Attendance complaints. Okay. You're saying DF not defined. If you're saying DF not defined, go and check your code from the top. Like, look at it from the top. Do you define your DF? DF is from here. From here, do you define it? Is it defined? DF, 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 DF. Do you define it? We are always we need that DF. When we get here, DF. When we do value count, when we get here too, DF. Right? So you need the DF. Like you are declaring a variable. You are assigning the variable, you are assigning something to something. So try that again. Run your code from top. Don't just come, and some of you just come to the class, start typing, and run. It will tell you something not defined, so go and define it. Now, when I ran this code, I saw something like, I don't like this color. I want the color to be different. I did the same thing. The only thing that is differentiating is this fine stuff. This is just showing that, okay, from what I did here, 1 is lesser, 0 is higher. But I want to define it. And I did another code again, but this code is long. I don't know if you can type it. But I'll just explain. Let me just explain. Because this is what this one is giving me. This one is giving me. So I needed to define it. I want to design it to make sure it's awesome. So what you do for me is this. Because of time, eh, copy this code here, this Seaborn code. Copy it out because I want us to be fast. Then anything you get, copy the code out, open LLM, paste it there, then prompt it. Can you help me? You can just say, can you help me to redefine? Just can you help me redefine, or can you help me add color? Can you help me add color and see what is going to give you? Then open another column and put it there. Then run it. So it will show you the color. To show you the color. So I don't want to run that. I want us to go to next one. I want us to go to Bosch Protest. So we'll look at the outliers. Look at how outliers are working. So you are with me, you are still with me. Say yeah, yeah. Everybody is running this code together. You are with me. Say yeah, yeah. I want to say yes, 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 yes. You are still with me. Yes. You are having one or two, maybe small, those small issue new, not big issue. If you have small issue, I want to see say those. Let us see. Okay, yeah, yeah. Correct. Correct. Yeah, yeah. I love that. Yeah, you are with me. Say yeah, yeah. If you have not with me, say yeah, yo. If you are not with me, say yeah, yo. Yeah. I want to see how we spell that Yayo too. Okay, thank you very much, everybody here with me. Thank you very much. Correct. So, okay. Let us say for your assignment, if you want color, if you want to add color to your bar plot, this bar chart, you want to add color, just like this bar chart here. You want to add color to it. Copy that code, just copy that code out and put it in ChatGPT or put it in the Copilot, put it in any store and prompt it. Say, I want this to be redefined. I want to add more color. I want to just anything, just think anything. The more you keep training, you are training the AI to LLM, you are training it. I love it. I love using it now. I'm not person that will tell you that don't use AI, do something. No, use it. Ask questions too. Some of these questions that people are posting on the comments, take the code there. Ask question. What is this thing doing? I've explained, yes, but what is this? What is this doing? What is this doing? Right? It will explain to you. Explain to you. AI, ML won't take your job. Right? It will take the job of those that can use it. Simple. That's what I'll say. It's those people that can use AI. Those people can do this simple stuff that AI won't take a job. If you can use it, AI won't take your job. AI won't take your job. So anything that is coming out, just know how to use it. Now, yes, I think I use AI for this to write this code. I just take out this stuff. I take out this one, this Seaborn, this pie chart. And I said, I don't want this in the pie chart. I want this code to be in a pie chart. See, I want just plot the pie chart for me and see what it gives me. Pie chart. It's even giving me the percentage. Right? It's giving me the percentage. Can we try it? Take that code out, showing your pie chart. Put it in your LLM. And I want the pie chart. So this is where something is tricky now. Let us try this thing out. So, okay. So, Femi said, yeah, thank you. Thank you. You can get into it and it can help you to debug right away. Correct. Correct. Thank you. Pama Yayo. Correct. And let us say yes. Okay, Yayo. I will think maybe okay, Yayo. Anyone, Yayo, please. Where do you ask us to copy and paste? Okay, go back to that buy chart. This one here. This one. We're still in Instagram. Yeah, we're still in Instagram buy chart. Just copy this one, take it to LLM any place and ask that, please, I want it to be in pie chart. It will do it for you. So if you have got it, just say Yayo. Simeon, I did not get the large language model, large LLM, large language model is ChatGPT. Large language is ChatGPT. Copilot is ChatGPT. What again? Can you mention all the new AI that we have? I have a lot to have. Pie chart, yeah, you correct. Thank you. Idami. The name is correct. You will see. Okay, thank you, Edivik. Thank you. Meta AI, yeah. Just work with it, use it. I think I was just like, what can I do to make sure this class is fast? What can we do? As we're doing it, let us be trying. And yeah, this is correct. Thank you, booking. Yeah, you. Now, okay, enough. If you have done that and then you bring back the code, you run it, and you see your visualization, your EDA stuff. Just I want to say, yeah, yo, yes, yes. Do we have GROK, Grok? I'm not saying about that. I'm not saying about the AI. I'll test it. I'll look into it. As a researcher, we start thinking as a researcher now. Like, let me test anything you see. Let me test it. How is it working? How can it help my work? Some of us are in no industry already. Okay, how can I apply it to my work? What can I use? Yes, yes, yes. Thank you. Gemini AI, correct, correct, correct. Now our time is running fast. Correct. Now let's go back. Let's continue. Let's continue. So the pie chart is giving us this. Right. So now you can now go back and start looking at, okay, PIP, this is where PIP is coming from. This is where the title is coming from, and it's showing again. I've explained it in Seaborn already. You cannot look at it. Okay. So the ability to, somebody asked me, what is programming? They asked me, what is programming? I said, programming, see my own definition. Programming is the ability to sit down for long. Or programming is the ability to be consistent. Looking at it, okay, this one is doing this one. Ability to sit down. You stay with it until I understand. And I believe we're only understanding the foundation. If the foundation is destroyed, what are you going to do? Correct. I'm looking for blessing. Yeah, blessing. Other boy. Yeah, thank you. Correct. So let's continue. So that's what I did for that. And now let's see Instagram. Let's see Instagram. So I have Seaborn Matplot is for Instagram. So I have created Instagram for BMI column. So I have this histogram, and I'm focusing on, in this histogram, I can focus on just one features. So I focus on just these features, BMI. Then I did a inbuilt functions, KD. I'm explaining that if it is true, then the color of my histogram should be sky blue, and mean to be 20. But I'm not the histogram. I don't want this. So let me just, please just flow with me. Let me look for, okay, this is another. I'm just playing now. See something I was just doing. I was like, I copied that Seaborn, then I just copy that part of the code, put it in AI. I said, can you just show me different type of EDA we have? Just give me the code. And as I was just getting the code, pasting it, running, I was playing with different codes. And I was seeing something like this, playing with it, showing me different type of codes. But I want this part now. This one is going to take long. Then it's showing all the stuff. So what concern for this class is histogram. Then we'll go to Biplot because of our time. I have a lot to say. So all these things is there's something that is doing this stuff. So I think it's another library, Plotly.express. So don't be confused. You don't need that for now. But I might just like exploring. Well, you're later something you can explore. Now let's go back to this. We have for histogram. We want to look at, let's go back to adaptive similarities. If EDA is explanatory, like when we are looking at features, we want to explain how the features are working, want to see what is happening, the distribution of the features. So when we get to MNI, somehow want to be boring, but if possible, I'll try my best to bring in explainable AI. Explainable AI is how the code, how the AI is predicting, detecting. If possible, I'll try to my best. I'm being in a training AI, so be seeing the pie chart by chart, because people, they like visualization. They want to see what is going on. So when you're doing your presentation, maybe to your client, to friends, and like, oh, this one is coming in, this one is going out, right? So so now what I did here is, so I just like I pick one, two, three, four, five, just five features that pertains to diabetes mellitus. Just five features. Any data set you're working with, look for few features that you want to work with. Actually, you get to a time where we'll be dropping some features that we don't need in the work. Then you'll be seeing something like this line here. I'll show us the code. I'll show us the code. But see something like this line then skewing down to right, like this is right skew stuff. Skewing down. Then something starts from E0. This line here start from E0, skewing down to the right. This one too from E0, skewing down to the right. This one too from E0, skewing down to the right. Now, in your code, we should be seeing on your data set, we should be seeing E0. E0. We should be seeing minus something. Everything is that's outline actually. We're talking about, I want to talk about outlines. Everything is I'll try my best to make sure I explain this part. Everything is good number. Okay, I can't go back. You are seeing good number for glucose, maybe you are seeing total number of 6, 7, 8, 9, then you now see 0. You show that that particular column, something is wrong there. So this is what this something is doing here. That we have few number of 0 here, and which skew to the right. Few number of 0 here. We have more number of 0 here, skew to the right, starting from 0, then more here. Then, but in data science, histogram, or this part is trickish. Please, you can listen. Most times when you're plotting histogram, or you want to do pie plots, or you want to do all this stuff, most time everything should be together. Most of the features, if there are features to be together, none of the features should start from 0. That's what I'm trying to say. None of the features to be scattered. Like all the features, maybe for the column, we're having 50 people, we have 75 people. Then next thing we are seeing like 100 scattered, different. It shouldn't be separate. I don't know. Like you are seeing for this distribution of glucose, you are seeing 0. The next thing is you're now seeing 50. The line now going and coming down. And that one again, for some of the data scientists and data analysis, you see something like that too. But I'm trying to explain. Then I'll write another code. It should show us how this is being. So we'll get more. When we get to bike plots, bus plots, we get to bus plot for outlines, we check for outlines. Now, this is the code. Okay, let's just do the code together. This is the code that is doing the histogram. The code that is doing the that is showing us the histogram EDA. For example, we have we'll show you myself. We have the Matplotlib. It can be fast, you can type it down, then there's a way you can prompt your ChatGPT, there's a way you can prompt your AI. Kai. You can just prompt it. You have the writing, please can you do this histogram for so. Then we have white gray. This white gray here is the background. Just this background here. Everything here I'm saying here is code. Everything here, they are all codes. I can change this into dark gray. That I want this thing to be darker, right? Then the features I want, because of time, I just pick 5 features: glucose, BMI, body pressure, skin thickness, insulin. I just need this for my work. Right? Then I want to see the histogram. I want to see the total number of people, the age, the group, the numbers. I want to see it. Then from there, I should be able to tell where 0 is coming from. Other people use histogram to just do their visualization, just to see how these things work. But as a data scientist, any EDA, any analysis you are looking at, there's something that you need to detect, you need to put. Then this is the code for the histogram. All this thing, this first one here is showing the size. I want it to be 1510. In your own end, you can put 14.5. Your own end, you can put maybe 10.5 or so. Just try something. Just change one or two stuff. Then for hiding feature in enumerate features, what this part is also saying for hiding features is a conditional statement. Not necessarily you know it. Just write the code down. Not necessarily that I must cram it. And if you are more smarter, you can copy. Let me tell you what to do now. If you want to get this code, like this type of my code now, ChatGPT will give you, or any LLM is going to give you. Just copy the Seaborn code, copy the first header, the first 5 header code, copy it out, then paste it in your LLM, just paste it there, then prompt your guy, just prompt it that you want this social code. You want the histogram plot the histogram code, then to generate this one for you. So when I did this and I run it, it's showing me how this is being done. It's showing me, and there's something, I don't know if I can remember, dark. I can still remember, okay, yeah, it has changed the color, dark view, dark gray, to still make it more darker, right? So, yeah. Who is asking what is histogram? Oluwatosin, we've talked about that. So, it's for virtualization actually. Histogram is for virtualization. You check it will check when you are using histogram, you check the distribution. Check for the distribution. So, got it, yo. Got it, yeah, yo. Thank you. I'm really giving us a way whereby we can be fast, like so fast. Like we can be fast instead of sitting down waiting for us like after maybe 10 minutes, 20 minutes writing this code. And if possible, you are fast enough, you can type this code out to show us this stuff. Now you can manipulate. Why Python is different from Excel, is different from other softwares or IDs or software environments, is because you can manipulate. You can just do one or two things. This I want my code. If you are running this code on Collab, you can copy this chart out. I don't know, maybe the new Anaconda Navigator, they have something you can copy. You can copy this out. Maybe you want to describe something in your company, and then they need the chart, right? So for every data analysis, except you're not a pro, pointing now, I don't need histogram. I don't need me. I don't need to be seeing my visualization again, right? Why I just do it, I write my code most times in scripting. I just run my code. I put everything inside. I put all my histogram. My own is I want to predict, I want to detect, I want to create a model to do one or two stuff. So I've done all my code, we cleaning, analyze, the main median, I've applied to it, scaling, please apply to my model and we're good to go. But for some of us that are coming from, you want to just know what your feature is doing and you still want to learn more, that is why we are doing all this stuff to know, to see how your data set is working. So as you are working with it, sitting down with it more and more, you will understand. Can you please do one of the prompts live, please? One of the prompts live, ChatGPT. Okay, I will do that maybe because of our time. I'll do that, Mr. Emmanuel. I'll do that. Maybe I'll drop this screen and I'll show us. Okay, if you're with me, say yo. Yeah. If you're with me, say yeah. Because you must run this code. If you have run your code and it is done, say yeah. Okay. Good today, thank you. Same people, so everybody's with me actually. I thought yo. Do say yeah. It's yeah. You have to say yeah. Correct. You see that analysis is simple. Though it can never be hard. You go back. Mr. Emmanuel Mega can never be hard. That is how it to be. You keep doing it. But you keep going back, 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 and then. Thank God for life of LLM self. Hey, I remember when I was doing, hey, Joy, why are you lost? Where are you lost? I'm lost. Hey, yeah. Okay, let's go to the next one. No be lost. So, here is the next one. Yo. Correct. Thank you very much. Now, I'm giving the interpretation of this one. I said should show a bell shape, look out for a zero value, which should not exist. Data scientists, machine learning engineer in this group, the artificial intelligence engineer, or anyone you want to call it. Anytime you are seeing visualization, look for a zero. Look for a zero. Look for something that is different. Look for something. Look at it. The one that is even worse is this insulin. It has more zero, and it's still to the right. More zero. Look at it. Imagine. It is worse. Which one again is worse? Skin thickness is worse. More zero. All these things, they're insight. Data analysis is insight actually. Before you start applying data machine learning. So this description, I'll be sharing this one with you. I'll be sharing this one. Skip to the right, look for the zero, what you need to do, apply imputation, then we need to apply imputation, value count, and then we've done all this stuff. We've done all this stuff. Now, boss plots, detect outliers. This is where I am going to. We need this. We need to know. See the boy plots we have here. Looking at this, you'll see something unique already. See, on insulin again. Oh no, is this one that is Baba? Everything about insulin is different. It's out of the link already. See, from 300 to 600. I'll be showing us. Maybe I'll do something. I'll explain that boy plot again. So, what is boy plot doing? Boy plot detect virtual outliers. So, boy plots provide a good way to detect outliers. So most times, numeric data set, if you are using numeric data set, you need a box plot. So it provides a good way of detect outliers by showing the interquartile range. I won't do any calculation. I'll just tell you how it is. I'll tell you how it is. Interquartile range is 25%, 25%, 50%, 75%. Interquartile range. I'm outlining extreme values. Right? Data analysis is simple. My Power BI make special customers. People say, all is well. So, everything here is still visualization. It's more of data analysis. So, but when we start putting one or two things inside, we are now doing machine learning. So, so outliers, just more of outliers. Now, see this simple code. This simple code. This is LLM. But if you want to type this out, you can type it out. Then type. So feature to plot. What I want is just feature to plot. Still, glucose, body mass index, blood pressure, skin thickness, insulin. Oluwole have taught us about outliers. Our work here is what we want to do. We want to just detect outliers. Maybe after this one, I'll just give us maybe a few class work. If you can work on it. But there's a lot. Outliers in each features. Because there's outliers in your features. The model we want, it will be given is zero. Or the model won't predict well, or something will happen. So everything we're still doing somehow, we are looking at our visuals, then we clean data set. So when you do these blood plots, again, see the way it is done. Now, the first one, glucose. This one is glucose. I'll explain this. In blood plots, there's something called, what Isaac has said, there's something called mean, median, 25% interquartile 25%. We have 75%, we have 50% or 75%. Most times, all your boys plot, all the plots should be in that range. Statisticians or mathematicians on this channel that as a listening, you should understand what I'm saying. Like your data set, that's what I was trying to say generally. Your data set should be in the range. It should be in range. Other something should not be. far from it, right? So from this line here, from this zero here, is 25%, 25% upward. This first one here, the down part, I'm starting from the down part. Then the second line is 50%, 75%. So everything should be in that range. There should be something, there should be features in that range. Right? Now, looking at this first one, glucose, we are seeing between 75%, 25%. Sometimes some people can write that code. It should just be in this middle. It will be in this 400 and 600 middle. But everything should be inside the box plot. That's what I'm just trying to say. Everything should be inside. Right? Now, from this is zero here. It shows that there's a features. There's something inside the data set that is zero. That's why this is zero is here. This cycle is here. But the other something is okay. This other something, the mean value and everything like that. That is to say, there's an explanation. I will show the explanation. Then this one too. We show that we have more. Why did I even write this code? Okay. Yeah. Okay, go ahead. But I want to just explain the visualization. I'm just going to explain like with normal understanding. I have more outliers outside, apart from this is zero, apart from the zero from this first place. I have more outliers, but not that too much. Identify away and not too far away. This one too. Outliers. All this is the cycles. The outliers. That's what I was trying to show us. Outliers, and then because I work with this one, I used to say zero outliers. This one too. Outliers. But insulin, Baba. Insulin is Baba of them all. All the outliers. Okay, everything should just be between 0 and 200. Though. 0 and 200. But we are having, look at it. We are having from, let us look at this part here, this one here. From 300 to 800, even to 900, even to 1000. All these things are outliers. We don't need this. The outliers. And insulin is one of the major features that we need to predict or detect diabetes. It's one of the major features. So we need to clean it. We need to clear the outliers away. Right? So this is what Oluwole was talking about. So you get me? You can say, yeah. Measure of center tendency. You can see measure of center tendency for this life. You can say, yeah. So this is what we actually need. Actually, we just want to visualize. We want to know where is there outliers in the data set? Is there something that is different? I will explain like this. We are talking about foods. We're talking about foods. Everything about foods is apple, cherry, mango, pineapple. Then somebody will just come from one place. Let me call one name here. Okay, let me say Dose Grace. Dose will just say food, and Dose Grace will just say monkey, goat. We're talking about food. Or we are saying outlines again. Let me come back to numbers. We're saying 1, 2, 3. Everything should be between 1 and 5. 1, 2, 3, 4, 5. Right? Then somebody will just come. Maybe let me call his name. Godwin. Godwin will just come and say, no, everything is not being between 5. Because you're not saying 59, 150 billion, 1 billion, 6 billion. So outliers, something that is far. That is what this blood plot is. That's what we want to detect, outliers in our features. Now, I want to do this again so you understand for the last time. Let's go back to our code. Go back to this part, then see this. Look at the data set. If you understand this, we are good to go. Look at the data set. Insulin is giving us problem. Okay, see, is 0. Insulin is 0. We're now having 64 and 94, 168. But when I do the tape too, we have 180, we have 112. But other glucose, everything is just moderate, maybe between 1 and 150 or maybe 1 and 200. See, glucose 148, 85, 83, just enjoying himself, 89, 137, blood pressure 72. But somebody just come from one place and they say 180, 112. If you look at data set again, you'll be seeing, if possible, I think 600. We don't need that. So this type of stuff, what we need to do to solve it, outliers, what we need to do to solve outliers is, most times, if you have more outliers, Oluwole have taught us, Isaac to have taught us, when I was working, one of my paper, one of my research work, it was on diabetes mellitus. And there's a way I used to code. I was like, yes, I know it's outliers. I need median. Median is just bring everything back, like in the middle number, right? Median is middle number. Those things that are not too far away, So just bring it and then pick the one in the middle, not too far away. Those one that are far away, clear it up. So I use mean in my work. I use mean on that. So what I did was I picked the most important fixtures, then I used the code to pick the most important fixtures. Then there's a way I wrote the code. So we can't be talking about. So this is what outliers is just doing majorly. So this is the code to run box plots. Another person can say, no, I don't want box plot. I want to do violin. Violin is another EDA. Violin is another EDA, right? And then try it. So try it. Let us run the code and see what it's going to give us. Run the code. Let's see what it's going to give us. How can I locate outliers in my data and deal with it, given that we will be dealing with a large data? I think I've explained that. So I'm already showing us here. I'm showing us outliers already. Those is a cycle up. Those cycle down. Those things that is different from the burst. If you don't see any cycle at all, anything in this cycle, okay, no outliers in that features. That is meaning no outliers in that features. But see anything cycle. So now let us deal with it. In the next 20 minutes, I think we have 20 minutes. Let us deal with this outliers, take it off, and we call it a day. Then next week we'll start, I believe, I don't know, maybe start with our model. Now start applying our model. Now we are just trying to look at the data set. We want to clean data set. Then next week we start our model, start predicting, start detecting, and we are good to go. Conditional formatting when cleaning your data set. I don't know. Because there's a lot of things you need to do. So I was now trying to look for outliers, zeros. This one is also look for zeros in my code. Well, we don't need this, we don't need this, we don't need this, we don't need this. What we need to do is we need to clean. So okay, I did an explanation here that we need a median. So it's in between 120 and 30. All the features are in between 120 and 130. Look at it. All the features here, between here and this place, they're in between 120 and 130. Then same thing for this one now. All features, maybe let us say between maybe 100 and this one. But all these things here, they're outliers. They are far from it. So I did this one. We'll be sharing this code with us, looking at the description. The count plot, we have done count plot already. Description, count plot is total number of people that have diabetes and people that don't have diabetes. And some of us have said 0 means non-diabetes, 1 means diabetes. Now, but we need to clean this. Scatter plot, you can try scatter plot. It's EDA too. Try it, but because of our time, just copy that code part, put it in any place. It will show you those small code. You can try it. Try the scatter plot. Let us clean our data set. Because if I start explaining and say what to write code, yes, we have one more. Let me explain this. Heatmap. Heatmap. I need to explain this. And two arts together. I don't understand you. The left side of each cell. What's left side of each cell? So we have heatmap. Heatmap is I think I've talked about that. It's just strong correlation. Strong correlation. So if you see something like this does a simple code to run the size, that is the size of it, by say 15, 8, or 9. As I'm doing all this simply running it, then we have correlation heatmap. The type of correlation heatmap. So what this is going to do for me is the heat map. I will explain this one. Very, very simple actually. Very, very, very simple. Now we have pregnancy, glucose, blood pressure, skin thickness, insulin, BMI. Now, when one of my work, I discovered that when I use heat map, I used to know the features I want to work with. I already know. Then I'll now run a code again if that is going to give me that same features. Now, what heatmap is doing is so strong correlation. It says that we have anything between between -1 and 1, between -1 and 1, right? So it's a strong correlation. So when it's going to 1, positive, going to 1, it is very, very strong, very, very strong. That is to say, it has a strong correlation with diabetes, or it has a strong correlation with what you're solving, right? The data set will tell you. Data set cannot lie most times. When you are cleaning your data set cannot lie. So you see something like 111111111. Let me explain this one for 11111. I used to say 11111 means you can't when you are doing strong correlation with yourself, pregnancy, that is to say pregnancy against pregnancy is still 1. Glucose against glucose is still 1. Blood pressure against blood pressure is still 1. But I want to share for strong correlation for pregnancy, just pregnancy against the target variable outcome, right? And for what do you call it? For BMI, for blood pressure, the one that matters to us now is glucose, blood pressure, skin thickness, insulin, right? So now, looking at this, we have pregnancy against outcome. It has a strong correlation. I think in the range. Okay, I want to make sure everybody is following. So we have pregnancy against. Let me reduce it so that you understand. Let me reduce it. Still, I believe you can still see it. Pregnancy against outcome is between 1, -1 and 1. The highest, this is already going higher. So we have 0.22. 0.22. Pregnancy is good to go. I can use it for my prediction. Glucose is the highest, is 0.47. Look at it. Look at this something altogether. You will see even glucose here is 0.7, right? We also have another one again. Age is 0.4, is 0.58, but it's age against pregnancy actually. But what concerns us is the most important. So we have glucose 0.47. We have blood pressure. No, which one do we have again? We have insulin. We have BMI against skin thickness. So what this something is just doing is a features against something that is high. Anyone that is high between -1 and 1, right? So I think I did I did the explanation here. So we have +1 is a perfect positive correlation. +1, let me add it back, is a perfect, I have to be fast now, is a perfect positive correlation. But the value is a range. Somebody says a range, -1 to 1. Then we have 0 means no correlation. There's no correlation with what we are doing. 0 means no correlation. Do you have anything 0 here? 0.00. Okay. Then we have -1 is perfect negative correlation. One increase while the other decreases. Now we are seeing this different type of color. The first color says the color bar on the right shows that the radar shade higher positive correlation. This one is higher positive correlation. This one here, this red bar, the radar bar. Then this one here is lower positive correlation. That is lower or negative correlation. So we see all this something, they are lower. All this color here, all this blue, small color, they are lower. And yes, truly, anything like blue, they are lower. They're all low, right? Minus 0.07, they're low, anything blue. But if you're going to red, thick red, from 0.4 upward, they are high. Now we now have that glucose versus outcome is 0.47. Are we correct? Glucose versus outcome is 0.47, correct? Moderate positive correlation. So higher glucose level tend to be associated with higher likelihood of diabetes. I think I've said that from the first class. Now we are seeing it again in our heatmap. We are seeing it now in heatmap, the correlation. We already seen it in our heatmap. So the stronger correlation with target variable outcome. So we have BMI versus outcome 0.29. We have age versus outcome 0.24. Let us look at it. Age versus outcome is 0.24. The one that matters actually. Heatmap, when you write the code, the heatmap will just pick the one that matters for us. BMI versus outcome 0.29. So we have age versus outcome 0.29. All these things, and I did the explanation here. When you check out the code, then we have low correlation with outcome 0.07 and like. Now let me ask this question before we call it. Then no, I'm not calling it a day. We have to clean our data set. We have to add one or two stuff, then run it before we go. So this one just so I have which one again? So what's the answer for BMI against BMI, body mass index against outcome on the live chart? BMI against outcome. The screen is now too small. Okay, let me enlarge it. BMI against outcome. What's the answer? What's the correlation? The number, I just need the number. BMI against outcome. 0.9. Thank you. BM. So 0.9. Thank you. So the highest correlation from -1 to 1. Thank you, Tun. Thank you, Yetunde. Thank you. One funny thing about this stuff is we don't need it, but we need to clear our data set for our next class. Oh, this is great. Okay, what of age against outcome? Age against outcome. Age against outcome. So we are looking at the outcome, something versus the last one. So don't be confused. These features against us. So the highest one, that's one we want to pick. And that's when we're not picking. There's something called feature selection. It's a code. There's a way you can write the code. If I add feature selection to here, there's something called wrapper method. There's something called wrapper method. Forward and backward feature selection. I use that in one of my work. Forward and backward feature selection. So what it's doing is just pick the best four that I want to use for my work. 0.24, correct. Can we clap for ourselves? Clap for yourself. That's great. Now, that is for that. Isaac have told us this normalization. I was talking about skewness. Like this thing is normalized already. We'll be sharing this. I want to be fast. Just show us 1-2 code before we go. Then this is just a sample inside my code, just to show how normalized code is. When something is normalized, everything, mean and median used to be the same thing. Mean and median, they are the same thing. Median, they are the same thing. Median, go for median. I'll be explaining that. You don't need this. Now, we need to replace zeros. No, I'll be talking about 0, 0, 0, 0, 0 from our class. So we need to replace 0 with none. Right? Non-values. So none means I think number out of something. You know that puts the explanation there. Yeah, it means okay, if we know. So we need to replace 0 with non-value, right? Replace 0 with non-value. Now, declare a variable. But this is what we are doing our cleaning now. Oh, thank you, Jumoke. Thank you, everybody. Let us write this code. It's in 4 minutes. Can you write this code? Not a number. Correct. Yeah. Thank you, Richard. Thank you. Not a number. Yeah. Let's forget. I want to just write my code. I'm not moving the screen too fast. See, data features. I want us to write this code. If you can do that, so that what I'm trying to say is, what I'm trying to show us is, you know, what I want to do is that is 000 that we are seeing. We want to replace it with not a number. Actually, this we want to replace it with not a number because this is where the cleaning starts from. You first replace it with not a number. Number is like a screen that some of this code knows about. You can't just put it zero to give us error. So that's what I'm trying to say, not a number. So now I'm trying to show us. The first one, it says replace zero. All those things we are seeing, outliers, something is moving, skew to the right, visualization. This is how you solve it. You now start saying, okay, should I use median? Should I use mean to solve my work? Should I use scalar? Should I use normalization? Should I use feature scaling? Because this is where you just do your research. Then again, you need to know if the type of model you want to work with. Maybe in the next class, I will continue this. I just want us to know this. What EDA? Suppose we shall take EDA last class. I'm just trying to take my time. So we understand what we are doing. Now, so this is where something is. We need to replace the zeros with none. Then pick what this code is doing is pick the most important feature that we need: glucose, blood pressure, skin thickness, insulin, and BMI. Pick it out. Then this code is saying replace zero with none. That is to say, this invalid value, you are declaring a value for this. Invalid value should be replaced zero with none. This is where the something is coming from. Replace zero with none. Then print is none. This none will tell us where the missing number is, and it tell us those things that is replaced. It will show us everything that it has replaced. We are not only sharing the slide, but also sharing this what I'm using to teach. We're sharing it. Then what I did was everything I'm doing, there's explanation under. You can look at it. It's not to explain. Yeah, thank you, Mr. Emmanuel, for saying that. So it will replace it. Then after replacing, and I do df.add. Now, see this first stuff, you now see that all zero is changing, has changed to none. Go back. When I go back to, I want to move my screen fast to here. I'm still going back there. Then see, this page is showing, this first one is showing 000, right? This page is saying is 0, the tail is showing 000. But when I replace zero with, I don't need zero in my work. Zero in dataset is an alarm. It's not good. So what this code here is just doing is that it is replacing zero with none. Replacing zero with none, and this is it. Zero with none, zero with none, zero with none. And after replacing it, the tail 2 replacing it zero with none. Replace zero with none. And lastly, let me do this. And let me just round off. Nan is a features maybe for this is how you do your mean, what Oluwole has taught us. 1 plus 5 plus 6. So what he's doing is the answer, the mean, if you just replace this nan, all this nan here, to replace it with your mean value for that features. Same thing for median, to pick it, right? This median, to place it with the best 5.0, 5.0, 5.0. So that is what we do in this place. Now, let me not boil us again. It's already time. I don't want to stress us. In the next class, we are going to be working with model. So in the next classes, we just do this cleaning. We'll clean it when it has replaced. Write the code. And that time, our body will have calmed down. We'll replace it. After replacing, then we will now do the mean and median. We do the mean and median. Everything will not change. Then we'll now maybe we want a voice plot again, or another EDA to check if they are going to still be outliers. We'll check it. And there's no outliers, we apply to our model straight. We bring in our machine learning model. Now, what I want from us is this. Go and start reading about. Only mentioned logistic regression last class. Start reading about logistic regression. Decision tree. Decision tree is a model. It's an algorithm actually. Decision tree, logistic regression, random forest. Just start reading it. Start reading how they have all these things we've done here is just more preprocessing. We're still preprocessing how they are related to your preprocessing techniques, right? Then again, in your lecture time, what I want us again is to, in the EDA section, do as many as possible. If some of you can still reach out to me, there's no problem. Maybe on LinkedIn, like if I can answer, I'll try my best to answer the one I can. Do as many as possible EDA and let me see if possible. But if not, practice as many as possible. Then the next class will continue from cleaning data set and we'll apply our models. And then again, we'll develop a system. That's our goal, develop a system. Right. So thank you very much for this class. And then yeah, you get all the slides and everything you need for the class. So thank you very much. I wish I continue, I can continue, but it's already time. My orgas, they're already telling me to fly. And then make sure we go back to the slide, go back to this course practices, do as many as possible, as many as possible. So that is how you can know more. Thank you. God bless us.
Dear DSA students, we are so excited to be on this journey with you, and we want to say a big well done for your commitment and enthusiasm so far. Whether you have just joined or you have been learning with us over the past few weeks, we see your progress and we are rooting for you all the way. Now, we know there's been a bit of silence around the learning management system, and we sincerely apologize for that. But here's the good news. We have an update as regards the learning management system, and it is one you'll love. Some of you may have been onboarded on the previous LMS, but want to ask that you kindly disregard any previous link, platform, or communication concerning that old system. We are officially switching to a new platform that you may be familiar with, Canvas by Instructure. For those new to Canvas, don't worry. A video tutorial will be uploaded to guide you step by step on how to use the platform effectively on our YouTube channel. You will also receive an onboarding email directly from Canvas by Instructure to help you get started. Please follow the instructions in the email and input your details to begin your learning journey on the platform. We are committed to making sure your learning experience is smooth, interactive, and impactful. So please, pay close attention to the announcements coming right after this video for more details. We are so glad to have you with us. Keep going, we've got this.